So on the warm-up, we've got the sum of the least and greatest of 3 consecutive integers is 60. So first thing is, I'm just going to write my expression for the 3 consecutive integers. So this would be my first one, and since they're consecutive, this would be my second one, and this would be my third one. Any question just on the representation for the 3 integers? Okay, now it says the sum of the least and the greatest. So here's the least and here's the greatest, and I want the sum. The sum of the least and the greatest is 60. And now I solve this. So I'm going to combine like terms. I've got a 1x and a 1x. That gives me the 2x. Bring down plus 2, bring down equals, bring down 60. Now I'm going to subtract 2 on both sides, and I get a 58. And now I'm going to divide by 2, and I get a 29. So my first integer is 29, my second one is 30, and my last one is 31. So those are my 3 integers, 29, 30, and 31. Did anybody get that? No? Okay. Okay. These were some of the harder ones that we had in that Delta Math, and remember I just wiped that Delta Math completely out because some of us could do it, some of us could not. I didn't want that Delta Math to drag out. So we're going to do another difficult one. Levon is older than Mariana. Their ages are consecutive even integers. So first of all, I got 2 of them. Consecutive even. So this would be the first one, and since they're even, that would be the second one. So I'm going to label who's who. Levon is older. So Levon is represented by x plus 2. Mariana is represented by x. Now I'm going to translate the phrase. It says the sum of Levon's age, that's this, and 5 times Mariana. So the sum of Levon's age, that's x plus 2, and 5 times Mariana. 5 times Mariana, that's just 5x, is 62. So now I'm going to combine like terms. 5x and 1x is 6x. I'm going to bring down plus 2. I'm going to bring down the equal sign, and I'm going to bring down 62. I'm going to subtract 2 on both sides, so I get 6x equals 60. I'm going to divide by 6, and I get x equals 10. And so Mariana's age is 10, and Levon's age is 12, and it says find Levon's age. So the answer would be 12. Did anybody do that one right? Okay. All right, laws of exponents, power to a power. So I need to raise 5 to the 4th power. What do I get? 625. Now I'm going to multiply power, so I get x to the 12th, y to the 4th in the numerator. Now because this parenthesis comes all the way down, I'm going to do the same thing in the denominator. I've got 20 raised to the 4th power. 160,000. I'm multiplying powers again, so that's going to be x to the 4th, y to the 20th. Okay? So now, it's a division problem. I am going to divide coefficients, so that's 625 divided by 160,000. I'm going to do math, frac enter, and I get 1 over 256. I'm subtracting powers, and if I just go ahead and put the variables where they go to begin with, then I don't have to worry about a negative power. So it's bigger on top, and I'm going to subtract, and I get x to the 8. Y is bigger on the bottom, and I'm going to subtract, and I get a 16. Question on that? Okay. All right, let's pull out our Halloween foldables, which is on laws of exponents. And we'll do a couple of these. Okay, hopefully, if I'm not mistaken, did we do one? We did this one? Yeah? I don't think we did anything else over here. Is that right? Yeah. Okay. Okay, so let's do this little fella here. Power to a power. So tell me about when I do -4 cubed. What do I need to do? Something special I need to do.
Don't you put it in parentheses?
The -4 has got to be in a parenthesis all by itself before I cube it. And if I do that, I get a -64. X to the what? Y to the, because I'm multiplying powers. Okay. Okay, let's do a hard one here. This little fella here. Okay, do y'all see how it's a power raised to a power raised to a power? Y'all, you can go ahead and fix that just by multiplying these two outside powers. So this is 2x to the third, y to the fourth, raised to the 6th power. Now, we need to raise 2 to the 6th power. What do we get? How much?
64.
Okay. And now power on the x? 18. Power on the y?
24.
There you go. Okay. All right. Trickier one. We've got one of these monomials raised to a power. Then we've got another monomial raised to a power raised to a power. So the first thing I'm going to do is fix this raised to a power raised to a power. So this is going to be -2x, and I'm just going to multiply those powers raised to the 6 right there. And I'm going to bring down this. Okay? Now I've got this monomial raised to a power and this monomial raised to a power. So let's do power to a power on the first one. So what's 4 squared? 16. And then x squared, y to the 6th. Okay. Then let's do it here. Let's make sure that we put our -2 in a parenthesis all by itself. What do I get? Positive 64, x to the 6th. And now, what do I do with coefficients? Coefficients. Multiply. What do I do with powers? Add. So 16 times 64. Okay. And then on the x, we're going to add powers. 6 and 2 is x to the 8th. And then we're just going to tack on the y to the 6th because there's no powers to add there. Okay. Good there? All right, let's do a couple on the division. Okay, negative powers. What's our deal with negative powers? Flip to red. So if we have a negative power on top, we bring it down and it's positive with the base. If we have a base to a negative power on the bottom, we bring it up and we can make that power positive. Okay? So this little guy here, what can I do to get those powers? Okay? Because the power of negative 10 is negative, I'm going to move that to the bottom and it's positive. I'm going to move the A to a negative 11 because the power is negative. I'm going to move that to the top. And now what do we do with powers? Subtract and get A to the first. Okay? Let's do this guy. Somebody tell me how to do this guy.
4 divided by 10.
Okay, 4 divided by 10, we could do that. There's something better we could do. We could look at our zero power rule. We could multiply 0 by every one of those powers. Or, what'd you say, Elizabeth? Or we could just realize that anything raised to the 0 power is and take a look. Everything is raised to the 0 power. Everything. That's number 1. Okay? Okay, let's do this one. This one's got a lot to it. Okay, so this power out here is positive, so I'm in good shape there. So let's go ahead and begin. I need negative 18 raised to the 3rd power. And by the way, Elizabeth had this idea. Y'all, if inside of here you want to do negative 18 divided by 3 first, you can do that. I mean, you can do that. I don't. I go ahead and fix the power to a power. Okay? So I'm going to do it my way. Negative 18 raised to the 3rd. What do I get?
Negative 5,832.
5,832. Okay. What do I do with powers?
Multiply.
Okay. So that's A to the 12th. Tell me about this one. There's something I can do with that. I can mark through it because remember, anything to the 0 power is a 1. I can just mark through it. Okay, and then on the C, I get C to the negative 24. Okay, let's do the bottom. What is 3 raised to the 3rd power? Okay, what's the A going to be raised to? 21. What's the B going to be raised to? Negative 12. And what's the C going to be raised to? 6. Okay? Got to do power to a power first, unless that outside power is negative. Now, y'all, the next thing I do is I want to get rid of the negative powers. And this is where in the last class I saw some big problems. Y'all, you don't just move everything. You only move the powers that are negative. Okay? So, y'all, the C to the negative 24 is going to move. And the B to the negative 12 is going to move. Nothing else moves. Nothing else moves. Y'all, a coefficient that's negative, y'all, that doesn't move. Okay? So, I'm going to leave everything like it is and only move those two things. So y'all, all I did was put everything back where it was, except for these two guys. I'm going to move this one to the top. And now it's a positive 12. I'm going to move that one to the bottom. And now it's a positive 24. Okay? And now we can begin to simplify. This is nothing but a division problem in the calculator. Negative 5,832 divided by 27. That's all that is. What do I get?
Negative 216.
Negative 216. Okay, I can actually go ahead and fix these A's if I want to. What do I do with the powers on these A's? If there's one on top and one on bottom, what am I doing with the powers? Okay, and where's it going to go to? Okay, so what's 21 minus 12?
9.
Okay. The B doesn't mess with anybody. We're going to leave him. Now, I've got C side by side. What am I going to do with those powers?
Added.
And there's your answer. Okay. Okay, let's stop there. Okay. So everybody put this on your whiteboard and see what you can do with it. It's 2 steps. I would do the top first, and then it's a division problem. All right, let's try this one. All right. Using these. Okay, the way I did it, and again, y'all, there's more than one way to do this. First of all, there's no power to a power, and you got to do those first, but there's not one. So, in my mind, I hate dealing with negative powers, so I'm going to move all 3 of those. But y'all, when I move them, everything else stays put. We don't move everything. So, I'm going to leave everything that does not have a negative power on it exactly where it's at. I'm going to move this one to the bottom. I'm going to move this one to the bottom. And I'm going to move this one to the top. That's the way I did it. Now, across the top, these are all U's, so I can add powers, and I get 9. Across the bottom, these are V's. I can add powers and get a 6. And nothing happens with the 4. Question on that? Some of y'all may have said, well, I just added powers here and got a negative 6. You could have, but then I would have moved that to the bottom and moved that to the top. What's wrong, Elizabeth? Did you not get it? Okay. What did y'all do first? Do you remember? So like you combine like terms? Okay, so you would get u to the 7th, v to the negative 6. Okay, then what'd you do?
We subtract.
Yeah. Now, this is where, and this is why I want everybody, this is why I'm going through this with them. Y'all, I would absolutely not subtract negative numbers. Can you do it? You can. Okay, and honestly, y'all, years ago, when I first started teaching, that's the way I teached it, but let me show you what you're actually putting in the calculator. Well, never mind, these, did y'all subtract here or did y'all subtract here? Y'all subtracted here, right? Y'all, this is what would go in the calculator. 7 minus a negative 2. And you're bound to miss this. It's too many. It's too many. Do you see what I'm saying? That's why I don't teach it that way. Can you get it right? You sure can, but chances are y'all missed one of these negatives. Okay? That's why I'm just like, let's fix this and take it to the top. Let's fix this and take it to the bottom. And then when you add that, you get u to the 9. That's why I get rid of those negative powers. Does that make sense? Okay. But doing it this way works. You just got to make sure you know, don't mess something up. So, okay. All right. Let's try this fella. Okay. Now me, y'all, could you distribute the negative? Absolutely. Me, I wouldn't do it. What's an alternative to distributing the negative power? What's an alternative to that? Nobody's listening. I can fix the negative on the 3 with one move. What do we do with negative powers? Flip to red. So y'all, all I'm saying is very quickly you could do this right here. And it's now a power of positive 3. That's what I would do first. Now, if you distribute the negative power, that's great. Guess where everything's going to wind up, though? It's going to wind up on the bottom anyway. Now you're doing power to a power on the bottom. All right, so 6 cubed, what do we get? 216. Should be on the bottom. Should be x to the 9th, y to the 21st, z to the 12th, and that should be on the bottom with a 1 on top. If you did not have the 1 on top, y'all, I can guarantee you on a multiple choice, that will be one of your answers to see if you forgot to put it on the bottom. Okay? Okay? One step. It's just one step. X to the negative 3 comes up. Y to the negative 7 comes up. My question for you, where's the 2 go? 2 stays at the bottom. Nothing wrong with that 2. By the way, what if this was a negative 2? Still stays at the bottom. It would still stay at the bottom. That's exactly right. Okay. All right. Okay, let's see. On the top, I've got a power to a power. 2 raised to the 3rd power. That is not 6. That is 8. M to the 6th, N to the 12th. Sorry about that. Okay, on the bottom, I'm multiplying coefficients. I'm adding powers. So that would be M to the 5th, N to the 7th. Now it's a division problem. 8 divided by 4 is 2. What do I do with powers? I subtract. 6 minus 5 is 1. 12 minus 7 is 5. That big old ugly problem simplified to 2m n to the 5th. Did anybody get that? Okay. Try that one. Okay, this is the order I did it. I went ahead and did this right here. And I know when I distribute, negative times negative is positive, so I'm going to leave that exactly where it's at. Where's the x going to wind up? On the bottom, and I subtract powers. Y winds up on the bottom. How about that? Those of y'all that distributed first, I want to show you what happens, because you can do that. This would be 2 raised to the negative 4th power, x raised to the negative 16th power, z raised to the negative 4th power. On the bottom, it would have been x raised to the negative 12th power, z raised to the negative 8th power. And then guess what you would do? Since all the powers on top are negative, all of that does what? Go to the bottom. Since all the powers on the bottom are negative, where are they going? But do you see I fixed it in the first step? So regardless of whichever way you went, you're going to have x to the 12th, z to the 8th, 2 to the 4th power, I believe is 64, x to the 4th, y to the 16th, z to the 4th, okay? See, that's what's going to happen when you move all those. And now it's a division problem, okay? Your 64 stays on the bottom. Where's x going to wind up? Where's x going to wind up? Because it's bigger, to the 8. Y to the 16th, we don't bother it. And where's the z going to wind up? Did I do something wrong? Because y'all look at me like I'm crazy. Jahira, what did I do wrong? Because I could have.
2 to the 4th power is 16.
Boom. Fixed. Thank you, girl. Okay, where is z bigger at?
On top.
So z's going to stay on top, and that's it. If you did it this way, you still should have come out there and then there. I like to get rid of my negative power on the outside first. That's just me. Okay? Okay.